Problem number 4 states, a water rocket is filled with water and compressed air. Just after the rocket is launched, water is exhausted from the rocket with a speed of 30 meters per second and at a rate of 3 kilograms per second. They want to know what thrust does the rocket provide. So, drawn out a figure here. We have our rocket going upwards, our exhaust coming downwards. We know the velocity of our exhaust is coming out at 30 meters per second, and that's coming out at a rate of 3 kilograms per second. And they want to know what the thrust is from the rocket. So we know thrust is a force, and thrust is a product of the exhaust speed and the rate at which fuel is burned, which are both of the variables we've been given. So we just have to multiply those two, 30 meters per second times 3 kilograms per second, and we know that our thrust from that rocket is 90 newtons. So fortunately for this question, we were given the variables, but if we weren't given those variables, we could also solve this using momentum, because we know force is related to momentum because the impulse, which is also the change in momentum, is the net force times the change in time. So we could always plug that number in, or we could always find that being given momentum or vice versa. So we also know that in the exhaust gas and rocket system, the momentum is conserved. So we know our momentum would be equal to the mass of the rocket times the velocity of the rocket plus the mass of the fuel times the velocity of the fuel. Final momentum is equal to initial momentum, which we know is mass times velocity. So we could use that information to solve other problems related to rocket propulsion.